Yo, kumusta? So ako to si Floyd ng Spec-Technology at magandang tanghali sa ating lahat. No? So, ayun, tapos tayo sa lesson natin regarding sa analog out. Ngayon is pagpapatuloy natin yung ating Zero to Hero Arduino full tutorial. Which is today is dalawa na lang, magkakaroon natin ng project. Included this video. So, isa na lang talaga. Ayun, so pag-uusapan na rin today is analog out. Okay? So, analog in na nakaraan, ngayon is analog out. Magpapalabas tayo using analog output. Okay? So, before we start, so kailangan mo natin maintindihan what is analog out in Arduino. So, open ako ng Paint. Okay? Explain natin. So, sa ating kung naalala nyo, yung ating digital out is capable lang yung ating digital pin to output 1 or 0 or correspond sa electrical perspective na 0 to 5 volts. This one is 0 volts and this one is 5 volts and 0 to 5 volts. So, ayun na yung kaya ng ating Arduino is correspond or represent sa program natin na this one is low and this one is high. Digital write high or low. So, ayun na yung capabilities. But today, using analog output, pwede tayong makapag-out ng ranging from 0 to 5 volts. Kaya tayo magpalabas ng 3.3 volts, 2 volts, 1.1 volts. Okay, before we get started sa programming, so kailangan mo natin maintindihan yung electrical properties o electrical characteristic or specification, whatever you call it, kung ano man yung gusto nyo itawag doon. At anyway, yung ating analog output is meron lang siyang specific pin na capable or may kakayahang mag-out ng analog in terms sa ating Arduino board. Okay, so we have 3 pin to 5, 6, 9, 10, and 11. Ayun lang yung tatlong pin na capable na mag-output ng ating analog out. Okay, or A0, call it analog output. Okay, so 0. Okay, so ayun yung pin natin na capable mag-out. So ano ba yung analog? Okay, so yung analog na ibig sabihin is like for example, we have this line here. Yan. So kung i-drop natin yan, this one is yung kanyang peak na 5 volts. Okay? And this one is 0 volts. So nakikita natin nagbabago-bago yung voltage na defend sa time. Okay? So with respect to time, that's analog output anyway, or analog signal. Okay? Sa ating Arduino, we have 8-bit resolution ng ating analog. Okay? Kung naalala nyo, yung ating analog in is 10-bit resolution. Dito naman sa analog out, okay, is meron tayong 10-bit resolution, which means that 255 sa normal or base 10 number. Okay? So, ito lang yung kaya ng ating analog output. Okay? Ano ibig sabihin ng 10-bit or 255 na yan? So, as you remember, so we have 0 volts up to 5 volts, right? Na kaya niyang i-out. Maximum 5 volts and minimum 0 volts. So, yung 10-bit resolution na yon is may apply dito. So, i-chop siya ng 255 na chop. Ganun kaliit yung kaya niyang ilabas na voltage. Okay? So, if we calculate kung gano'n kaliit yun, so we have 5 volts divided by 255. So, we have 0.019 volts yung kaya niya ilabas. 196. Okay, 196. Okay. Volts yung kaya niyang ilabas. Okay. So, ibig sabihin, this one is here is 255. Yan. And 0. So, ini-scale niya yan. So, ayan yung ating representation ng ating analog. Pero dito is hindi siya pure analog, yung output ng ating Arduino. Okay, so ano yung ibig sabihin ko na hindi siya pure analog? Okay, pag-uusapan natin is yung ating PWM. Okay, or yung ating pulse width modulation na sinasabi. Okay, so think about this one. So if we have this graph, at ito yung ating signal, this one may 5 volts yung peak and 5 volts and 0 volts. Okay, so yung kanyang output is something like this. 5 volt peak. Okay, so yun yung kanyang ina-out. So 5 volts pa rin to, this peak here, 5 volts and 0 volts. So paano nagkaroon ng paano mo makokontrol yung voltages? Okay? So, sa ating analog, meron na tayong tinatawag na duty cycle. Okay? At saka yung period or frequency. So, this one, let's say example, is 1,000 milliseconds. Okay? Ayan. And yung on stage natin, I call it this one here. I call it this one here is yung ating T1. And this right here is yung ating T2. Okay? Ayan. Okay, fixed to ha. Depende sa frequency ng analog output mo. Okay? So, pwede mong baguhin yun using Arduino code. So, sa timer counter naman natin mag-usapan at medyo advanced na po yun. Anyway, basic lang tayo. Like for example, yung ating T1 here, T1 is 500 milliseconds. Okay? Maliit na M yan, milliseconds. Of course, yung ating T2 dyan is 500 milliseconds din kasi fix yung kanyang period. Okay? Yeah, so 500 milliseconds din. Okay? Sorry. Seconds din. So, ano ba yung average output niya? Okay? Ano ba yung voltage pag check natin using tester? Ang average voltage niya is something like this. So, 1,000 milliseconds. Ito. Yan. Divided by 500 on stage niya. Okay? Okay, ito yung on stage o Taiwan natin yung effective na or effective power natin, this one. Ito. Okay, so hindi natin kailangan to. So, ito na yan. So, ang sagot dyan is 2, right? 2. So, yung pinaka-highest niya is 5 volts. So, 5 volts divided by 2 is equals to 2.5 volts. Okay? So, ayun yung average voltage niya pag yan is niread ng ating tester at ipapakita ko naman sa inyo yun in actual later on. Okay? And, like for example, this time, yung T1 natin here is 250 milliseconds. Of course, yung ating T2 dyan is, since fixed nga to, depende sa frequency, kung Arduino mong gamit, is to 750 milliseconds. Ngayon, ano ba yung effective power niya? Yung effective power niya, which is 250 milliseconds. So, we have 1,000 again, divided by milliseconds, divided by 250 milliseconds. Cancel equals to 4 na lang. And 5 volts divided by 4 is equals to 1 point something. Okay. Practically that. 5 divided by 4 is equals to 1.25. So, we have 1.25 since dito voltage. So, that's how ganyan ginagawa ng ating analog output, yung ating kung paano niya binabarage yung voltage using this, ang katawag dito is PWM o yung ating pulse width modulation. Okay? So, since yung 0 to 5 volts natin is nare-represent ng sa programming natin na dapat 0 to 255, yan, 0 to 255, yan. At yung pinakamaliit niyang kayang i-out is 0.0196 volts. Yan yung kayang i-out. Okay? So, ibig sabihin, if gusto kong magpalabas sa aking pin number 3 or 6, 5, 9, 10, 11 na ganito, 0.19, 0.0196. So, ang ilalagay ko lang is analog right equals 1. Okay? So, hindi equal sa or 1. Okay? So, pwedeng AR, yan, pin number, and lagay ko lang dito is 1. Okay? So, ayun yung ating analog output. So, okay. So, para maintindihan natin, i-actual natin later on yung ating analog output. Pero naintindihan nyo naman some of the basic kung ano ba talaga yung ating analog. So, hindi siya pure analog. So, nagbabarid lang yung kanyang voltage in form of PWM or pulse width modulation. Okay, so tignan natin yung ating circuitry. Okay, so gaya ng sabi ko, meron lang pin na capable to output analog. That was 3, 5, 6, 9, 10, 11. So, hinook up ko yung aking LED. So, since meron pa rin tayong limit na 5 volts and yung ating LEDs meron lang limit na 30 milliamps. So, that's why we put 220 ohms resistor and yung ating LED. So, from pin number 6, which is capable to output PWM, connected to one the leg of the resistor, and yung other end ng ating resistor connected sa ating positive or longer leg ng ating LED, at yung shorter leg or negative leg ng ating LED is connected sa ground. That's how it looks sa ating breadboard. Okay? So, if you view into a schematic diagram, as you can see here, is D6 of pin number 6 connected to the resistor and LED. Naka-forward bias yung ating LED going to the ground. So, that's how it looks sa ating circuit diagram. Okay? So, here is yung ating hookup. And don't worry, by posting this video, i-include ko na rin yung this link para magaya nyo. At lalagyan ko na rin ng code here. Lagyan nyo lang yung code and select text here and go simulation. At pwede na kayong mag-simulate using virtual. Okay? So, kahit wala pa kayong actual video, nyo kayo use thinkercad. Okay? To simulate or to para lang magaya nyo yung ganito. Yung circuit sa virtual. Anyway, so open lang kayo ng ating Arduino at dapat meron tayong ganito. Okay? Hindi to necessary, pero every time na magko-code ako, lagi ako ini-include yung serial just in case na need ko mag-debug or mag-check ng mga kung ano man yung gusto kong check na data o kung tama ba yung calculation ko. Anyway, so ayan. So, yung ating LED is connected sa ating pin number 6. So, try natin muna i-circuit diagram itong ano to. So, in actual. So, nakikita nyo, we have LEDs, 220 resistor, and breadboard, of course, Arduino, and a jumper wires here. So, I have this jumper wire. So, unahin muna natin yung pin number 6. Yan. And kukunik ko sa aking LED. Here. Yan. So, after that, yung aking LED, yung longer leg ng aking LED is connected sa one of the leg of our resistor, and yung other leg ng aking LED is connected sa GND. Here. Okay, it doesn't matter kung saan GND. So, eto, nilagto tayong GND sa ating Arduino. We have this GND, and same GND lang naman yan. So, here, everything's correct. At nandyan na yung ating circuit diagram. Now, try natin i-program. Since yung aking LED is connected sa aking pin number 6, so, int ako. So, hindi natin naintindihan. Kung hindi nyo alam yung int, please watch my other video or hintayin nyo yung kasunod natin na video. Siguro after ng project pa. Okay, regarding sa basic variables natin. Okay, at saka data types. Okay, so this one is, pangalanan ko siya ng LED red. Yan. And equals to pin number 6. Yan. So, yung LED red natin is serve as an output device. So, iset ko yung pin number 6 as output. So, I call pin mode to specify yung specific pin as an output. So, copy ko lang to LED pin, which is sa loob dito is meron tayong 6. So, logically, pin number 6 yung gagawin natin output. Now, we declare yung ating pin number 6, which is connected yung ating LED doon as an output. Now, we can do, kung naalala nyo dati, sa ating digital is we call digital write. Now naman is analog write. Naman tayo. Analog right, sorry for that. Analog right, here sa analog light, dalawang parameter yung kailangan niya. Saan pin ako magbibigay? Okay, sagutin natin yan. I call it LED red, and how much power I give. Okay, gaano pa kalakas na gaano kataas yung voltage na ibibigay ko. Remember, we have limit from 0 to 255. Like for example, I put 255 muna just to see or makita natin yung ating LED. Yan, para makita natin yung LED, yung maximum brightness yan. Okay, so, para makita ng ating camera. So, just gaya ng dati, so select mo lang yung ating Arduino board, hindi pala kasama yung ating port. Select natin yung ating Arduino board, Arduino Uno, and after that, tools again, and select yung port. Kung hindi nyo alam, please watch my previous video. In-explain ko kung saan makikita yon using device manager. And everything set, try to upload, medyo matagal sa ngayon. So, pause ko muna yung video para di tayo tumagal, but if we encounter na error, ay hindi na pala kailangan. So, yan. So, may na-encounter tayong error. Ang sabi dito is, pin mode is not declared in the scope. Okay, kasi nga, mali yung spelling natin. So, case sensitive yung ating C+ language. So, please, careful kayo. Okay, so naging variable siya at hindi natin na-declare dito yung ano ba yung pin mode na yun na nakaka-uppercase yung O. Okay, everything's good. Okay, everything's done. And yep, so ayun yung maximum brightness ng aking LED. But if I have put 10, minimal or sobrang minimum, malapit na siya maging 0. Tingnan natin kung magbabago yung kanyang brightness. So, ayan, medyo lumabo siya. And take down note, etong numbers na to is range lang siya from 0 to 255, which is 255 is fully 5 volts or fully on, fully brightness, and 0 is fully off. But etong numbers na to, pwede nating gamitan ng ating variables. Like for example, int, I call it analog value. Yan is equals to 0 for now. Like palagyan natin dito na 255. Yan. So, pwede siyang mag-change. Copy ko lang to at i-paste ko. Wala problema. Okay? Kasi pag tinignan niya ng ating Arduino here, pag tinignan ito ng ating Arduino, is titignan niya yung loob ng ating analog value since nag-declare tayo dito ng variables na analog value na may laman na 255. That's why 255 yung ilalagay niya or maximum na value natin. See? Okay. If I change this one into 5, like for example, tignan natin kung bababa or magiging minimum, magiging sobrang liit yung ilaw nito or hindi ganun siya kaliwanag. And yan, so hindi siya ganun, nag-dim siya. That's how we do sa ating analog. And as I may promise na totoo ba na bumababa talaga yung voltage niya pag sinukat natin ng tester. So meron akong tester dito. Here. So, hindi siya ganun hindi siya ganun ka-accurate, but pwede naman natin quick reference na naman kung nagbabarig ba talaga yung ating voltages. Okay? So, lagay ko lang yung aking this one and lagay ko dito. At kung nakikita nyo, 0.1 volts yung nilabas niya. Okay, so hindi, kaya nasabi ko, hindi siya ganun ka-accurate. Okay, anyway, so pag babaguhin ko to, gagawin ko naman tong 255. Upload natin, supposed to be makakuha tayo ng 5 volts. And ano lang siya, 3.4 hindi maayos yung aking tester kasi okay, wait lang. Okay, wait. So hanggang 4.35 lang siya, 4.35 volts. So check natin yung pinaka-supply niya talaga kung talagang umabot ng 5 volts kasi nakasaksak lang sa USB natin. At nag-drone siya ng mahina lang kasi naka-extended USB port ako kaya nag-distribute yung power kaya mahina na lang yung bigay ng aking USB or supply nitong Arduino. But I can use naman other external power supply kagaya ng buck converter na nandito. Pwede ko supply niya para maging 5 volts pero checkin muna natin kung ilang volts pa talaga. Okay, lagay ko lang sa 5V here. And as you can see, ang pinaka-supply niya is nasa 4.58 lang. So, if I remove this LED, ground na lang kayo na. So, if I remove this one of the leg of the resistor, tignan natin kung magbabago. Ayun, naging 4.84 na siya. So, malaki yung voltage drop niya kasi mahina lang yung power source natin, which is yung PC natin. Okay. So now, ngayon, here sa ating paint, so, hindi natin alam, like for example, if I put if I put uh, 100 dito, ilang volts ba yan? Kung wala naman tayong tester, okay? So, ilang volts ba yan? So, try natin. So, from analog here, so from analog na nilalagay natin sa program, try natin i-bring back into a real voltage. Ipa-calculate natin using formula. So, yan. So, 100, na-upload ko ba? So, upload natin. Ayan. So, one thing pa is papakita ko naman using ating oscilloscope. So, I have this oscilloscope dito. Mumurahin lang siya. Hindi rin siya ganun ka-accurate. But, mas maganda na ito para reference ng ating waveform. Okay? Hindi nyo kailangan na magkaroon nito. So, mas maganda kung meron kayo ganito. Okay? So, in-upload natin pero hindi nagbago yung kanyang voltage. Naging 4 point something pa rin. Yeah, 255 nga natin ulit. 255. Kaya hindi siya nagbago. Hindi ko nabalik sa pin number 6. I'm so sorry. There. So, balik natin sa 100. Tignan natin kung ilang volts. Upload to. And there you go. 1.69. Okay, so ito naman yung aking oscilloscope. So, wait lang. So, pause ko lang yung video. Saglit. Okay, so ayan yung ating waveform. Kung makikita niyo, talagang square wave siya. Right? Baguhin natin yan. Like for example, if I put 10, so nakikita niyo yung kanyang on stage, medyo malapad pa siya. Here, so medyo malapad siya. Ayan, tignan natin kung minipis siya. Okay, so yun, minipis siya. Okay, so that's how PWM works. And kung gawin naman natin na 190, almost 250, so tignan natin. So, ayan. Nakita nyo, bumabago yung kanyang on stage. Okay? So, na-prove natin na talagang pulse width modulation siya. Hindi siya pure DC. At nagbabago-bago lang yung kanyang on stage, yung duty cycle niya, para magkaroon ng average voltage dito, pero hindi siya pure DC. Ngayon, is gagawin natin is yung analog output na to, ito, analog out na to, is checkin natin kung ilang volts ba to sa program. Okay? So, here, alam natin, basic math lang naman to. Alam natin na tina-check to ng 250 at yung pinakamalit yung voltage is ito. So ang gagawin natin is yung ating analog out na gusto natin is i-divide natin into maximum limit niya na 255 at kung ano yung voltage ng ating maximum voltage niya, which is pwede maging 5 volts here, 5 volts. So checkin natin yung ating maximum voltage kung talagang 5 volts ba talaga siya. Okay, so lipat ko ulit to sa ating PCC, so sa ating 5B, para makita natin. Now we have 4.89. So we have that. Okay, wait lang. Oh, nag-short siya. Nag-short yung aking oscilloscope. Yan, okay. So, we have 4.59 volts yung maximum natin. Nilagay ko yung pin number 6. Okay, nilagay ko yung pin number 6 pero hindi na gumana yung camera. Post ko lang video. Isip ko lang may technical difficulties tayo. Okay, so ayun. So, yung ating voltage is around 4.55 or 54, 56 kanina. Nagkaroon lang tayo ng difficulties sa camera, 55 or whatsoever. Anyway, so hindi to 5 volts here. So, dapat ito is 4.55 volts. Okay? So, now, going back to the program. Balik sa program natin. So, gawin natin, float tayo. Kung hindi nyo alam yung float, please watch my previous video at sinabi ko doon kung ano yung float. Yung float natin is can handle decimal value. O kaya ulit voltage is equals to 0 for now kasi i-operate natin yan and we'll do basic calculation. So we have this an analog, right? Dito. So we have voltage is equals to open and close parenthesis. Kung nakita nyo ating formula, analog value, yung gusto natin na maging output niya, and we divided into 255, lagyan natin ng 200 para maging float siya, and we multiply it by 4.55, and that's good. Now let's see if i-print natin yung ating analog value and yung ating voltage. Like for example, if I have this serial that print line, so tsaka nyo natin alamin yung print lang, walang line, saka natin alamin kung ano ba yan. So but for now, so tandaan nyo itong calculation na to and put natin yung space and just copy this and paste it at the bottom and remove this double quotation mark para maging variable siya, and this one is lalagyan ko siguro ng and point out and copy ko lang to and paste ko lang sa baba and I call it voltage, this one, and this one is voltage and LN. Okay, everything is good. Upload natin and let's see, compare natin sa tester natin versus sa ating serial monitor kung talaga bang sakto yung ating calculation. Okay, and open natin yung serial monitor natin. And you have C is 3 point something, 3.39 volts. So bakit naging 3.39 volts analog value is 4. Okay, so bakit hindi siya naging ganun? Kasi yung ating yung ating positive is connected pa siya sa ating DCC kasi connect natin yung reference voltage natin. But here is makikita natin na 3 closely siya na closely what do you call this, close siya sa ating 3.39 volts. So pwede naman natin baguhin yung ating reference voltage, like for example, ano ba yung pinakasagad nito. So check natin yung pinakasagad 255 or lagyan nyo na lang calibration factor pag hindi, since ito kasi hindi naman to calibrated itong part na to, at nung check natin yung 5B is hindi naman talaga yung pinaka 5 volts niya, and 255 volts and 3.30. So this one is 4.30. Upload natin. $4.30. Okay, so try to check 190, sorry, and 3.20. So ayun, naging exact na siya, or 3, meron na siyang konting nagbabago, pero 0.02 is not kaya nasabi ko 0.96 yung pinakamaliit yung voltage. Dito sa ating calculation is 0.20, but dito is medyo nagbabago-bago siya. Okay, so ayun yung ating analog. So if you wish na talagang gusto nyo hindi ganito, hindi siya pulse width modulation, gusto natin i-convert into straight line talaga, like for example this one is 3.2 volts na straight na hindi siya ganito, hindi siya ganyan, pwede naman lagyan natin ng low pass filter. Okay, so right nga. So okay, so ito yung ating Arduino, at connected sa ating pin number 6 and GND this one. So lagyan natin ng low pass filter. So para sa low pass filter, capacitor lang naman kailangan natin. Pero kasi yung ating Arduino, yung ating pin ng ating Arduino is only capable to draw 40 milliamps. Okay, pag nilagyan natin to directly ng capacitor, may tinatawag tayong rush current ng ating capacitor. Magpupull siya ng mataas na current para mapuno agad siya ng mabilis. At ayaw natin mangyari yun kasi pinoprotektahan natin yung pin ng ating Arduino. So remove this circuit diagram dito, which is mali ito. Okay, so lagyan natin siya ng ating resistor dito. So lagyan natin ang ating resistor. And for now, and then tsaka natin lagyan ng ating capacitor, electrolytic capacitor, dapat more than 5 volts siya kasi 5 volts yung ano natin. Mas malaking farads, much better. Ito na ngayon yung ating B plus and B minus. Okay, or 0 volts natin. So ito is nilagyan ko lang siya ng 250 ohms. But if you want, so gusto natin dito is hanggang 40 milliamps lang yung magpo-flow sa kanya during charging. We can calculate naman, like for example, this one is 5 volts, so R is equals to voltage divided by I. So we can put now 5 volt this one and 0.04 amps. So if we calculate that is 5 divided by 0.04 is we have 125 ohms. So, dapat hindi siya bumaba. Pag bumaba siya, hindi na siya 40 milliamps. Pwede siya mag 50 milliamps, so whatsoever. Okay? So, that's how we do. So, gusto natin makita in actual, why not? Walang problema. Check natin yon. So, tandaan natin yung ating circuit diagram. Low pass filter. So, we have P number 6 connected the limiting current resistor and then electrolytic capacitor na pwedeng 16 volts lang to and much higher farad or microfarad, much better. Okay? So, gawin natin yung ating circuit diagram. Remove ko lang yung mga ating test probe. Okay, so instead of LED, we can replace this LED na capacitor. So, and now I have a capacitor na dito. So, ito yung aking capacitor. Kung makikita nyo, meron yan negative na line. So, that's negative. At makikita nyo, shorter leg yung negative. Shorter leg yung negative natin. Ayan. So, yung shorter leg or negative probe ng aking capacitor, lagay ko lang sa akin GND. Okay. So, magtatap ako ng pin for probing as dun sa circuit diagram. Ayan. And this one. Okay. Right. So, kita pa rin ba yung aking ba natin lagay? Yan. So, nakikita nyo ang aking oscilloscope. Now, if I probe yung aking tester, wait lang. So, positive, this one. So, dapat is 3 point something volts pa rin siya. Okay. Wait lang. Wala yung kanyang kapasitor. Okay, so nagbago na yung ating voltage. Yun na yung Y kasi kung dito is naging 3.53, 52 na siya. Bakit? Kasi nga nawala yung load. Okay, so nawala yung voltage drop, na-replace naman siya ng capacitor. So if we do check again, 255 lang natin. And is 4.70 something, 75. So lagyan natin dito 4.75. And lagyan natin na 190 and check natin. Okay, so now is medyo okay na siya. And kung makikita natin, yung ating tester is nagsasabi ng voltage. Now, yung ating oscilloscope naman is pa-plug in naman natin sa ating okay, yan. And this one here. Okay. So, makikita natin na straight na talaga siya. Pag tinanggal ko yan, bababa yung line na to dito. So, pag tinanggal ko, bumaba. Okay. So, pag tinignan natin yung yan. So, yan is sa pin mismo. Sa dito yan. So, pag yan is dito yon. Dito ako nag-hook up ng aking yan. So, dito ako nag-hook up ng aking probing, ng aking oscilloscope. But, pag hinuck up ko siya dito, pagkat dito, nakaparallel sa aking capacitor, is makikita natin na straight DC na siya. Okay? So, that's how we do yung ating PWM. Okay? So, meron tayong low pass filter. Okay? So, pwede tayong gumawa ng inverter using that low pass filter. Mababa lang to, 40 milliamps lang yung kaya nito. Itong circuit na to, kahit pure DC na yung output niya, pero mababa pa rin siya. Nasa 40 milliamps pa rin yung kaya niya, the range of 5 volts. But we can amplify that signal using transistor. At yan yung pag-aaralan natin sa ating home automation, sa ating project sooner, siguro after ng basic Arduino. But alam natin kung ano yung properties ng analog at paano gumagana yung ating both input and output analog and digital like input and output also. So, next tutorial natin is about if statement. Doon na tayo gumagawa ng decision making at doon na magsisimula yung totoong programming session talaga natin. Okay, so hanggang dito na lang. And once again, I'm Floyd from the Spec Technology at magandang hapon sa ating lahat. Mag-iingat po kayo palagi. Maraming salamat.